Well, hello, brother or sister CNCer. I am Garrett with IDC Woodcraft, and I'd like to welcome you to this video. What we're going to be covering in this video is the spoil board for the Longmill 30x30 CNC router. When I upgraded to the Longmill, I wanted to make sure that I did things right this time. I used to work with the Bob's CNC E4 and learned a lot from it. So my spoil board needed to be just right. I needed to make sure I had pass-through capability. I wanted the right grids on it and various other things. Well, when I started to get into designing it up, I had no idea that it was going to turn into the project that it turned into. But that's because I wanted to make sure I had things in place in the beginning. Unfortunately, every level I get to, I'm thinking, oh, I need to add this, I need to add that. It just got to a point where, Garrett, just make the damn spoil board. Well, I did. It didn't come out right. And that was my fault. Because when I bolted the Longmill to the table, I didn't make sure it was square. And that posed a little bit of a problem. And if you don't put your Longmill on the table square, it'll run into a problem for you, especially when you have to do two-sided jobs, which this spoil board is a two-sided job. Now, right now, it's just a blank. So you're going to get to see it being cut, and I'm going to talk to you about all the things I've done to it as I've gone along. Because I ended up having a scrap spoil board, I was able to push the machine through some of its paces. Figured I'll just use that board to test it out. This is the scrap spoil board that I tested it out on. And I've got to tell you, I pushed the machine really, really hard to do some of this stuff. And I've got to say that it performed much better than I expected. These drill holes, 3/4 of an inch deep, plunged at 125 inches per minute on a spiral drill cycle. Here's a quick example of some of the paces I ran it through. What you're looking at here is a 3/16 down cutting bit, the one I just added to the IDC Woodcraft store. It is doing a spiral plunge drilling cycle. The feed rate is 100 inches per minute, and it's going 3/4 of an inch deep, and every rotation of that is 1/4 inch. So it takes 3 circles to get down into the material, and it cut it like butter. The next was to run a really aggressive cut. This is a 1/2 inch deep slot going at 125 inches per minute, well above the recommended feed rate. And the bit was driving right through the material. The machine was not bogging down at all. So between the two, the Longmill was performing exceptionally well with such an aggressive cut. And the bit was holding up well too. This is a 1/4 inch deep cut at 125. I was checking the consistency of the swirl, and that held up really well. This thing did really, really good. Did stars, used a 120-degree V-bit, which I'm telling you, if you make flags and you're using a 90-degree V-bit, dump it. After doing this and then doing this with the 120, it's like 5 times faster than the 90-degree V-bit. And here's the 120 actually making a star, and you can see that it completed the star in 2 passes, whereas a 90-degree V-bit is going to do it in about 5 passes. This star is a little bit bigger what you typically carve on a flag. This 120-degree V-bit has also been added to the IDC Woodcraft store. Longmill didn't have a problem with this carve. All right, so let's get over to the router. And what I'm going to do real quick here is talk to you about how I goofed up on the squaring and how I got it squared up. And then I'm going to talk to you about what I'm going to be doing to create this spoil board. Now quickly, just before I get into this, I just want to let you know, I got some information at the end that I want to share with you, so stick around because you want to hear about some of this. All right, let's get going. So the squaring aspect is really important because if the machine is out of square, your projects are going to be out of square, and it'll jump out at you like night and day if you have a two-sided job. With the squaring, the length this way, from this rail to this rail, is fixed by the V wheels that ride on it. So when you're back there, there's a fixed distance. When the gantry comes all the way to the front, it's a fixed distance. So that's not a big deal. It's this way that it will show up if you don't bolt this thing down square. And that's exactly what I had. What ultimately I had done was this rail was a 1/4 inch ahead of this rail. So this was a 1/4 inch back. And when I flipped the board over, I was almost a 1/2 inch out of square as far as my drill holes were going. So that's a big deal. How did I fix the problem, and how do you fix the problem? Well, don't fix the problem. Get it right the first time. Here's how I did it. I took another blank piece of material. I got the measure between the 2 outer feet when the gantry was by the feet. And that turned out to be 36.25, dead on. You can see right here, that's butted up against there. And right over here, it's butted up against there. I apologize for the background beeping. Can't help that. I'm in a store, and we are in the back of the store, so we have to have the beeper. So I cut that 36.25, which is what you want to do. And then I cut my length, was 40 inches long. In metrics, it's 960 by 1016. Now, this is a little flexible. You can go a little longer if you want. The critical thing was making sure that this angle is 90 degrees and that angle is 90 degrees. That has to be square, because what we're doing is we're using this front edge as the reference line to get this leg and this leg lined up. So now I got my feet. They are even with the board. I've done a test cut to verify. I did 4 little pinholes, and they have a known distance of 42 inches apart. So it's there and there and there. And then I was able to take an 1/8 inch diameter pin, put them in the pinhole, run a tape measure across, and get my measure to the center of each hole. So I am maybe about a 32nd of an inch out. I'm very happy with that. So when you bolt your long mill down, bolt one side down, make your board like this, 36 1/4, dead on, by 40, slip it in there, and then get this side lined up properly, and then screw it down. And I just want to make a note, make sure you screw it down on the inside. The outsides are angled, and when you do that, it'll push the whole thing in. So you want to get the insides all screwed down first, and then use these just to draw the feet down to make sure they're sitting flat. Now that I've got everything set up, I can now start to cut my spoil board. Now I want to make sure you understand something here, that this is oversized. About that much will be waist, and same on the sides. This is spoil board is going to be the size of the router cut all the way around. And I'm going to make a note for you if you want this G-code on this spoil board. When you assembled your long mill, in the instructions they had the anti-backlash nuts, and you have the M5 socket head cap screw. Well, this screw is going to take up some of your travel on this side, going up and moving forward. If you want the G-code to the spoil board, you need to take this one out and put the set screws in that they provided, because that spoil board is written for max travel of this machine. All right, so let's talk about the spoil board and what it's going to have on it. The first thing is locate holes. Because there's going to be an operation on the back side, I need to make sure that when I flip it, it is located exactly where it's going to be. So the reason I need to flip it is because I am putting these rivet nuts into the board, and I have to create clearance for the flange of the nut. So I have to flip it over to get that little clearance pocket. So I'm going to have 4 locating holes, and it's going to be just somewhere out here. And that way, when I flip it over, I can take this bit or anything that's an 1/8 inch diameter and put it in that hole and that hole or this hole, and that'll realign the board the way it needs to be. Now, this is the bit we're going to be doing the first part of the work on. This is a 1/8 inch diameter upcutting bit. We are using this to drill the locating holes, the screw down holes. There's going to be 16 screw down holes throughout here. We're going to counter bore for those screws. The screws I'm going to be using are going to be number 8 inch and 3/4 inch all-purpose screws. The head is going to be counterbored so that it is out of the way. If you want this G-code program for this Spoilboard, then you will have to have the 1/8 diameter upcutting end mill, because it is written with this particular bit in mind. You can get these bits off of the IDC Woodcraft store. This will be sold as a set, 2 bits and a collet, so you have your backup bit. Now the thing with drilling on a CNC router, it does take a special technique. So I will shoot a video about that in the future, is how to do that. Again, if you want these bits, they'll be available on the IDC Woodcraft store. There'll be a link down below so you can order yours. Let's get to drilling his first sets of holes, and then we'll move on to the profile, and then we're going to flip it over. We're going to do the counter bores for the rivet nuts, and then we're going to bring it back and we're going to do all the grid work. So let's rock this out. So using the 1/8 upcutting bit, the first thing we're doing is cutting the counter bores for the screws that are going to bolt the plate to the table. This too is a spiral plunge drilling cycle, and we're going 1/4 inch deep. If you want to drill on a CNC router, I strongly recommend that you always use an upcutting bit and a spiral plunge drill. If you're going to do a peck drilling cycle, I have to teach you how to do that. Now we are doing the through holes for the screws. And you see I'm using a very small spiral to get through it, and how fast it's going through it. If I was straight plunge drilling, it would break the bit at a rate like that without coming out to clear the chips. I have videos about this. So a little bit of deburring on the project. So at this point, with the 1/8 upcutting bit, we've cut our 4 locating holes, so when I flip the board over, I'll be able to locate it. And we've cut the screw holes for the all-purpose screws. Now we're going to get onto the 3/16 down bit, and we're going to cut out all the top sides of the rivet nuts. And we're going to profile out the spoil board. So we've swapped the bit out, and this is the 3/16 downcutting bit that I've added to the IDC Woodcraft store. Now, just so you know, that bit is designed so you can go through up to 1 inch material. Again, we're using this spiral plunge drilling cycle, 100 inches per minute. I'm always interested in why Vectric sets up its toolpaths in such funny ways. Next thing we're doing is going to do the profile cutout of the board itself. We are running at 100 inches per minute again at 1/4 inch deep. And you see the bit is just going right through it. Now, one of the things that I was impressed with right off the bat was Longmill was holding up very well on the dimensions throughout this entire project. And it makes me think of mudding right here, right, with a Jeep. When you're doing this type of work with a down cutting bit and you're going that deep, you want to make sure you keep the narrow slots clean. So now that we've got that done, we're going to do a little bit of cleanup and sand up the edges. Side 1 is done. I've cleaned everything up very thoroughly and flipped the board over. And now I have my locating pins in the board, so I can't move the board. There's one there and one here. And I know I'm in square because I'm straight all the way down. And you see there's a little bit of a lift here. So there's a little bit of a bow that's in this board. That's easy enough to take care of. I'm going to clamp it down by using this scrap material. It'll just clamp right down onto these boards and push it down, and I'll hold it in 4 places, and then we're going to go around and do all these little counter bores and then flip it back over. Now I got the board clamped down, and I'm using the clamps I made. These guys here. That you can get this on Etsy, where you can make 21 clamps of your own instead of spending $50 for a set of 4. You'll have a bunch of wooden ones, and the good thing about these is you can run into them and your machine will cut right through it instead of breaking your bit. So if you're interested in that G-code program, you'll get instructions, and the G-code, you follow the instructions to start your machine, and about an hour later you have clamps. So there's a link to this file on Etsy down below in the description. All right, so now we're going to run out the counter bores for the backs of the flange nuts. All right, so for the most part, we're pretty much on. We're a little bit off center, but that's why make the flange holes just a little bit bigger than needed. So now you're going to insert the flange nuts before you turn this thing back over. What you do is run a bolt into this backwards, and you hammer it down until it doesn't go anymore, just like this. You have a screw, you put it into the back of the nut. Don't run it all the way through, just enough till it just comes there. And then all you do is just start pounding them in. Well, that took about 15 minutes, but now I've got all the rivets pounded in. I was too short, so I made sure that they were on the most distant area of the router. So it'd basically be these 2 holes when I flip it over. All right, it's time to flip it over. Before I put the Spoilboard back on, you can see I went through with all the rivet holes, but what I want you to see more is the locating pin. That was the first one, so that's no good. That's the locating pin right there, and there's one right there. These other holes are for the screw that's going to go through to hold the board down. I wanted that hole because typically with the MDF, when you run a screw in, it gets that little mushroom shape there. So I did that to avoid that. Now it's time for step 4, surfacing. So we're using the 1-inch surfacing bit. We're using a 70% step over with this bit, as you should. I have quite a few videos regarding surfacing bits. One of them is why you have to have this in your CNC router bit arsenal. Number 2 is how to design up a Spoilboard surfacing program using the surfacing bit. And number 3 is how to set up the feeds and speeds for these things. Links for those videos are down below in the description. Now the 1-inch diameter surfacing bit, you can get this off the IDC Woodcraft store as well. There's a link for that down below. Typically I'll surface about a 0.01 off of the board, but in this case I'm going up a little bit higher from my 0 point being on the surface, because I want to shave off as little as absolute possible on this thing. So we are going to do a skim cut. Now this is traveling at 100 inches per second, or maybe 120. Well, I surfaced the Spoilboard and forgot to turn the camera on. Don't worry, you're not missing much. The Spoilboard has now been surfaced in both directions. So what I'm going to do now is seal it with polyurethane. I'm going to use the water base. Now you might be thinking, why in the hell would you seal your Spoilboard? I don't know, seemed like the right thing to do. Actually, I'm just sealing it against humidity variations. I am in a garage and I am exposed to the outdoors a lot because I open the door. So when I seal it, that'll prevent some of the expansion and contraction that goes on in the MDF. I'm going to use a little technique a friend of mine taught me, where you take that, use a roller, and then I'll take a heat gun and dry it up real quick. And then I'll put another coat on. Take the heat gun, dry it up real quick, and another coat. The heat gun, dry it up real quick, and that'll seal the top of this board. And then what I'm going to do is I'm actually going to paint it, and then I'll cut the grids in there. It's actually really easy to do. Just pour a little bit of the polyurethane on the board and roll it around until you cover it up, and then use your heat gun to dry it out and pour some more on. Get a good coating on it, level it out, dry it out, and do it once again. And now you've sealed the top of your board. Now, just so you know, that little technique of using the water-based urethane and taking a heat gun to dry it off, and I did it 3 times, took a half an hour, and it was dry. I could go right into painting it. So if you want to like speed up some of your work, use the polyurethane that is water-based, put multiple coats on it, and use your heat gun. And then you'll have to sand it down when you're done, as you normally would anyway. And now it's time to paint the spoil board. Maybe a little crazy, but now it's time to let it dry overnight, and we're going to carve it in the morning. This is about the final stage of the whole process. Right now it's carving information on the board. It tells about dimensions and where things are located at. Then it goes into the numbers of the grid. Everything right now that it's doing is text. And then we go into the circular part of the grid. I added this just because. I don't know how I'll use it, but it's there. And then one of the cooler features is the inch scale. It goes along the X and the Y axis. Looks like a bullseye. And finally, the grid itself, which is 4x4. And there it is. That's the spoil board. So it has the grid on it, an inch scale. All the information about the grid is on there, how it's built up here, and all the dimensions. Just where everything's placed at. This is a 4x4 grid. Have all my clamp nuts in here. So I am very happy with this. There was one spot a little bit low here for some reason. I'm not sure why, because I was able to use the facing tool on it, but inconsequential in this case, since it's the far corner of the machine. I'll never use that part of the grid. Next time I would probably laser burn this as opposed to paint it. And that, my CNC router brother or sister, is the spoil board for the Longmill CNC router 30x30. Now don't go away yet. We've got to rehash a couple things because I got to make sure you remember this, especially if you want this G-code program to make your own spoil board in the same way. The program, by the way, will be available on Etsy with instructions, so you will know exactly what to do. So 2 things you have to make sure you do is on your anti-backlash nuts, all 4 of them, there's 1 on the Z, 1 on the X, and 2 on the Y. You have to remove the M5x25 socket head cap screw and put it in the M5 set screw. That'll take up or remove this distance that's causing your machine to lose some travel. The spoil board is written for max travel, and this will be in the way. Your spoil board program will not run right. You also have to remove the vacuum bracket attachment that would be on the side of the spoil board. Make sure your machine is square. Very important, or when you flip the spoil board over, it'll be out of square. It'll be out of square when you make it. Now, one of the things I want to ask you, if you would please, if you are in the market for a CNC router and you decide to get this machine at Longmill, then I want to ask you to please use the link down below in the description or on my website, idcwoodcraft.com. What that does is give me a little commission on the sale of the machine. And maybe for me helping you, you can help me out. So if you would, that would really be great because I love teaching you anyway. Okay, we got a couple other things we have to cover. The clamps. Don't buy clamps you don't have to. You can make your own. You have a machine that can make them. And I have made a G-code file that's basically plug and play where you can make like 21 of these things. The reason I did this is because inevitably you are going to run into your clamps and you're going to break a bit. It just happens as a part of CNCing. And if you have a metal clamp, you are going to break the bit. And you don't want to do that, especially when you have a $30 or $40 bit. The soft pine clamps, the bit will drive right through it like it wasn't even there. So get that G-code file for this down below in the description. There's a link to that on the Etsy store as well. And then we covered a couple other things. One is the surfacing bit. You have to have a surfacing bit. It's just one of those necessities. You don't use it that much, but when you use it, when you need it, you need it. There's no other bit that's going to replace it. And that's used for surfacing your spoil board and fixing botch jobs or smoothing out some wood. You have to have this bit. This is available on the IDC Woodcraft store, and I have several videos about this, how to set it up, your feeds and speeds, down below in the description, of course. You can find that information. And then we talked about the 120-degree V-bit. After I used this, I was kind of like, I'm not using a 90 anymore. On stars, on text, unless it's really small text. This was so much faster. Blew the 90 out of the water. So I've got this, I call it the little stiffy, because I had it short, designed it short on purpose. So that you have to grab it like that. Because when you're starting to use wider bits, you're going to get vibration if you don't make sure that it's rigid. Finally, if you're brand new to CNC routers or the design work, subscribe to this channel because I will teach you step by step everything you need to know. I don't do just like average videos where you walk away feeling like you didn't get all the information and you're going video after video after video after video. I will walk you through every step of the way and various different things. Try to give you everything in layman's terms. Sign up for CNC Insiders. The link, of course, is down below. CNC Insiders is an email list where you will get access to discounts that I'm getting hold of and other information. If you want to make money with a CNC router, sign up for the CNC Entrepreneurs Facebook group. I formed that group with one mission, to help us CNCers help each other make money with our CNC machines. Lastly, just want to remind you, please use that link if you're going to buy the Longmill. It helps me tremendously, and I'll thank you for it in advance. If you felt like you've got something out of this video, give me a thumbs up, and I'd love a comment. And happy CNCing. I'll talk to you next time.